Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. Welcome, everyone, to Happy Path Programming.
We're back after a while because you've been traveling.
It's just, that's the life of a developer advocate.
On
the road.
Do they still do that? They still do the developer advocate thing, huh?
Yeah, now I just try to convince agents.
I see. You don't have to interact with actual people.
Now I'm really an agent advocate.
Oh, okay.
Yeah. But the human connection going to in-person events has actually become, I think, more valuable because we as humans like to connect in person.
Nice.
And here we are on we're together, but our guest today, Sune. Sune. It's Danish, right? And so,
exactly. What's your last name? Debel. Depel. That's not easier either. So it's a real tough one. Sorry about that.
Sorry, my Danish is not awesome. But we've got a good one so a quick little background story. So this was like 3 weeks ago. You and I got together on our weekly get together. I was actually in town and
Tech night.
Yeah, our tech night, and
which used to be book night,
and now it's
like I'm not sure what it is anymore. We're still figuring that out.
Yeah. But we
have we officially given up on TypeScript? I know nobody wants to do it, so
the book feels so close. Like maybe I'm imagining it. Like the hard parts are kind of done, maybe versus not really.
We could just do what
but
I'm doing.
I kind of want to finish the TypeScript effect-oriented programming book.
Okay.
Maybe I just do.
We could just.
I think you and Bill are done with TypeScript.
I don't want to know about it any more than I have. But the pros could be done mostly with Claude, I think.
Yeah. And it would probably still have value.
Oh yeah.
Yeah,
I think so.
So we'll see on that. But okay, so we were together, you and I, and we're like, let's just ask the AI if it can find anything related to effect-oriented programming in Python, because you've been doing a lot of Python. You've been coming back to thinking in Python, your book that you
there's a little bit of story behind that because I started it in 2008 and I abandoned it. Like I wrote a blog post saying, this is why I'm not doing this book. It's just, I don't know what I said. It was too hard, I guess. And then a couple months ago, I thought, well, let's just see what Claude can do with it. And then I started pouring all of my presentations at PyCon and other, all the research that I'd done, I poured it into it. And I said, okay, put this in and all the stuff from the design patterns work. And I just kept adding to it, and it kept doing a good job. And the tooling, it did a really excellent job for me.
Tooling, you actually have the code, and then you have it run, and then you capture the output, and you do validation.
Yes. Oh, yeah. Everything. So everything is run and validated, and run through all the type checkers. And
because it sure is annoying when there's code in a book or anywhere without it, any kind of example code, and then it doesn't actually work.
Oh yeah. That's basic. And then I had it do this thing that I've been wanting forever. And I have made multiple attempts at it, which is to put the output directly in the listings. And I know you can do that with doc test, but it just looked too ugly to me. And so, and it did it, and it works right. And if there's any little hiccups, it fixes it. It's like, I would never have been able to write this book, and certainly never have made it to where I wanted to. So that said, we started looking at your library.
Well, the AI helped us find it.
Oh yes, the AI helped us find it.
I don't know. We probably could have just searched Google or something, but
maybe I don't know.
But anyways, we had done that before. We asked AI help us find some things that are kind of effect oriented in the Python world, and for me, I've always been kind of a Python skeptic because, I got total functional programming pilled and so there wasn't really the effect-oriented stuff in Python that would make me want to use Python. And so we're like, hey, let's see what's out there. And then we found Stateless. So
we found Stateless.
Yes.
And then Monday, because I knew we had this podcast coming up, I thought, well, I need to spend time looking at this. And I started looking at the documentation, and I thought, why don't I just have Claude write me a chapter? We'll just put it tentatively, put it at the end of the book. And this is Thinking in Python, and you can find it at thinkinginpython.com. I'm not saying it's done, but it's still it's usable. Yeah. It's usable. Yes, there needs work on it, but I mean,
yeah,
it's workable the way it is.
So you've got a few chapters that kind of lead up to Stateless, and then
there's a
Stateless.
There's a whole section on functional programming.
Yeah,
and then right before Stateless, initially the generators were in the Stateless chapter, and then I broke them out because it turns out that's easy to do.
Yeah,
you just tell it to do that, and it does it.
Yeah,
and so there's a generators like where it goes into depth because Stateless uses generators very intimately, and then now there are two chapters, one which is the Stateless introduction, and the other is Stateless in practice, which has as many examples as I could pull from the effect-oriented programming book and other things. And so, yeah, it's a whole deal, but I have not combed through it and, rewritten the stuff
you haven't deslopified it yet.
Well, I mean, everything works and the prose is, tolerable, but I often come and I find some sentence I'm going, what does this mean? And then it will fix it, and it will then go explain why there was a dangling pronoun or something, and it explains that why the sentence didn't work, why it was confusing, but then it fixes it. So I haven't done all that with this yet, but
so. For Sune, tell us about what is Stateless, this library that we've been.
But also, what's your background? Where did you go to school, and how did you end up?
Definitely. Yeah, and thanks for that chapter in Thinking in Python.
Two chapters.
I think that is 2 chapters. Yeah, I think that's probably the most comprehensive documentation that exists on this library so far. Even more comprehensive than what's in the README. So that was entertaining to see. I mean, I skimmed through it. I didn't read it.
I only told you about it last night.
Yeah. But nothing stood out to me so far. I think it looked pretty convincing. So
right.
Good job with that so far. But yeah, my background is kind of mixed. My education is mixed. Also, partly as a software engineer from the IT University of Copenhagen, and then I did my master's in kind of data science, very focused on natural language processing at the University of Copenhagen after that. And that was something like 10 years ago that I did that. And then I've been working as a kind of very hands-on data scientist, sometimes natural language type engineer at various companies, but mostly at startups and scale-ups, where part of that job description was also data analysis and data engineering. So that's
you've been doing a lot of Python through.
Yeah, I've been doing a lot of Python, for sure. But also in periods, a lot of Scala, which is where I was exposed to ZIO, which really caught my attention as something that proved to be very useful for writing real business applications.
Was that your first exposure to effects?
I mean, I probably saw some Haskell code in university, but I never really applied it to any real problems, and I don't think I really got it the benefits of it when I saw it in university. It wasn't really until I really tried it in practice with ZIO that the penny sort of dropped for me of what is actually the tangible benefits of a system like this. I mean, I'd also have some experience hobby level with Elm that I enjoyed a lot, where you get some of the same benefits in a more limited or maybe less flexible way, very intentionally by Evan, I think. So
Elm was such a good way for people to start to dip their toe into the waters of effect-oriented programming things. It had, immutability and, a lot of the...
Did it have effects? I thought it was just functional.
Maybe it didn't.
It's a functional reactive system, right?
So functional reactive.
The effects are managed by you emitting some value that the effect system handles, and then it produces a new state that you need to.
Yes, I guess in some ways it is effect oriented,
but it didn't seem obvious when I was reading Elm. It was just like,
but there is like a runtime that is handling essentially mutations,
right?
And,
updates,
the workflow of page updates and stuff. So that'd be interesting. We'll have to have Evan on and ask him if it's truly effect oriented and get his thoughts on that. But cool. So you got some Elm, you got some Scala ZIO, and then also like Python in the day job. And so, at what point were you like, I should build an effect system for Python?
So that was when my job description changed enough that Scala wasn't really a substantial part of my day-to-day job, and I was really missing that experience in Python. And so I thought, well, why not just try to port ZIO into Python? And so I had an adventure with that, which was not super successful, I would say, because it turns out that, well, the experience of doing monadic stuff in a language that doesn't have do notation and for comprehension is just not very nice. And also,
the people that say like ZIO, at least the model for ZIO is not easily ported to other languages. One of the primary reasons why is the lack of higher kinded types in some of these in other languages. So I don't know if that was part of what you ran into there.
Well, actually, that was part of the reason why I thought that ZIO was a good model for Python, because ZIO does not actually depend on higher kinded types for most of its bag of tricks. Yeah. So you can get pretty far with that representation without higher kinded types. And Python, for the audience members that are not intimate with the Python type system, does not have higher kinded types. So that was part of the reason. I had dabbled in other types of monad frameworks for Python before, and I always came back to, well, without higher kinded types, it's just not really practical to do effect composition type stuff. But in ZIO, you don't actually need higher kinded types for effect compositions. And so I thought, well, maybe this would work out. And from a typing perspective, it worked out great. But just from an ergonomics perspective, and I guess also partly from a performance perspective, it didn't work out that great because of trampolining in Python turns out to be kind of expensive, and because function calling in Python is expensive. So it was just not a very great experience all in all. But then at some point, I tried to fix the ergonomics story by doing this trick that other people have done when doing monadic stuff in Python, which is to use generators to introduce a kind of do notation in Python. So the way that works is that you have this is a common thing in a lot of libraries that tries to do either types or other types of limited monad stuff in Python, is that you have a decorator that expects a function that returns a generator, and then that will basically interpret the values that are being generated, and then it sends it back in with a closure basically. But then while I was doing that, it occurred to me that you actually don't need the closure at all when you're using generators, because a generator is a coroutine. And so you can use the coroutine as a way of suspending and resuming computation rather than the closure. And that turned out to be a real powerful simplification that just made the whole machinery click in a much nicer way than if you try to do closure-based stuff in Python, I think. So eventually I kind of moved away.
A handler, right? I mean, a handler like they have in some of the native
algebraic
effect languages, right?
I would more phrase it as the generator plays the same role as the closure does in traditional monadic systems, right? So in any effectful system, you need some way of suspending the computation and allow the effect system to interpret whatever operation it is that you want to make. And then once the result of interpreting that operation is ready, you need to resume the computation with that result, right? And in functional languages that use monadic style, you usually do like that with a closure.
Yeah. This is where
so it's basically like it's like a continuation passing style, right? Where you write. So bind is basically continuation passing style, right? You supply bind with a function that represents the rest of the computation. And so the trick that I'm doing is stateless is I'm just saying, well, if you're using coroutines, you can just use the coroutine to represent the rest of the computation directly. You don't actually need the closure.
Yeah.
Now, there are some trade-offs with that
replacing the continuation.
Yes, exactly.
Right. Okay.
Yeah. And then you get the generator syntax gives you the ergonomics that feel better than if you didn't have generator syntax. It would you could probably have the runtime handled. I mean, maybe you just go back to thunks or whatever, but the ergonomics just wouldn't be very nice to work with.
Yeah, exactly. You get rid of all the problems that you have with callbacks and continuation passing style, which is basically just a story as old as time and very familiar to anybody who's worked with async await before async await, basically, when everything was callbacks, right? That's just not a very nice way to write or read code, generally speaking. And I think it's part of the reason why do notation and for comprehension exists in the first place is that you need some type of sugar to make it palatable in languages like Haskell and Scala.
Yeah.
So that's exactly right. That yield
make
from
it look imperative, but when it's really not traditional imperative.
Yeah. Yes, exactly.
Or at least yield and resumable without the usual noise but with the imperative style. Yeah. Yeah, so you were like, hey, I think this could work on top of generators, and started building Stateless. And real quick to hop back, was your ZIO attempts under Stateless, or was that a whole another repo or something? Just I'm curious if there's a historical artifact we could go look at just to see how that experiment turned out.
Yeah, there is. It's another repo under my GitHub handle, also called pfun.
Pfun.
It was kind of it was a missed opportunity, actually. That. Obviously, it should have been called PO, obviously. But of course, somehow that name slipped me at the time.
Yeah, PO would have been good. So cool. That'll be fun to go splunk through pfun. So then when you had the realization that generators could be the basis for the ergonomics of a factor-oriented system in Python, that was the creation of the Stateless library.
Yes, but then I also started researching a little bit, and it turns out this is not really a new idea exactly. Actually, people have been doing this for a while. So it was interesting to see that other people had the same idea. Just I don't know that anything exists in Python that uses this technique specifically.
And the technique with the generators, or the technique that's the more kind of algebraic approach, or both?
The technique with the generators. Yeah. So I should say that Stateless is essentially, it is an algebraic effect system. I think it's fair to call it that, but it works essentially the same as an algebraic effect system built on a monadic representation. So it's not algebraic effects in the same way, I think, as it is in OCaml or Coca or some of these languages that have algebraic effects natively. But it is more similar to the style that you have in Haskell with the if. Even though I'm not super familiar with that, but
the free style. Yeah.
Yes, exactly.
So what kind of limitations do you run into using the generator approach?
The main one is that unlike a continuation function or like a closure, a generator is a one-shot computation. So you can only resume it at most once. So that means that there are some effects that you can't express with this representation that you can express in a normal monadic system. And that would be something like the list effect or like a choice effect where you have a non-determinism, or you want to run the same computation on multiple inputs. You can't do that with generators because that would require you to rewind the generator to a previous state and replay it basically. And I don't know if that is technically impossible, but at least that's not how Python generators are built.
So in the case of, let's say, a repeat, like
because you have a repeat,
like how you would do a repeat or a retry on a generator.
Yeah, so that brings me to kind of the other limitation of generators is that they are stateful objects. That's so the name Stateless is actually kind of tongue in cheek because it's it's a joke on the fact that I'm trying to build a purely functional effect system on a mechanism that is inherently stateful, which seems like a crazy thing to do. But the way that I get around it is that I use decorators, which is another Python concept quite extensively. So most places where I need to manipulate a generator, I don't accept a generator object directly. I instead accept a function that can produce a generator that I then decorate, and then you can supply the arguments to that function. So that means that the generator that Stateless is manipulating is not something that you as a user of the library get to hold a reference to. So that makes the whole thing essentially referentially transparent, even though I'm working with mutable objects underneath.
Yeah. So let's just take an example of a repeat. You'll have a repeat function, and you can't just give it an instance of a generator because it would only be able to do that repeat once, which wouldn't make sense. So instead, you like thunk the parameter to repeat so that you can then recreate the generator on each iteration.
Yes, and then rerun it.
Right?
Yeah, that's exactly right.
Let me ask, this is just a thought, but do you think there could be such a thing, like this would require a PEP or something, but as a repeatable generator? In other words, could we either add a repeatable generator to Python or modify the existing one so that it could be repeatable? Is that practical, or is that?
It's a good question. I actually don't know how generators are really implemented in CPython.
Yeah.
But what I imagine it is some kind of stack frame with some kind of state that tells you where in the code you are at. And then when you send a new value to it, it resumes until it reaches another yield point. So I can't think of a reason why it should be technically impossible to do it. I imagine it's probably pretty hairy stuff to get into in C, but I can't imagine a reason why it should be impossible.
Yeah,
I really doubt that it's going to happen, though.
Hey, stranger things have happened in this language. Yeah.
There's got to be other uses in Python more generally for this beyond the world of FX. It seems like.
Yeah, well, I mean, the story the story and the terminology of generators and coroutines in Python is kind of a complicated one because basically Python today has both terms in play because the async IO framework in Python uses coroutines. Mm-hmm. And so they have essentially the same problem, right? That you cannot await a coroutine more than once because it's the same kind of mechanism, right? Mm-hmm. But I mean, a generator is also a coroutine. You just don't call it that in everyday Python speak because that would be confusing because they're used for different things. And it used to be that they could sort of be used interchangeably, or at least you could supply a normal generator to a sync IO also. That's frowned upon now. I think it's you get some kind of deprecation warning if you try to do it. I think it still technically works, but
yeah. For a while they were thinking of maybe we can use generators as coroutines for async IO coroutines. Yeah, but then it's
interesting there's a meta concept here that I've seen in a lot of different languages, which is you've got a coroutine that is the like single operation, single result kind of thing. And then you have something stream oriented as well. And the two are usually totally different APIs for good reasons. Some languages put the the coroutine, the single operation thing on top of the stream one and just only read, one result out of the stream, which ends up having some performance challenges down the road. But so there's these two different concepts. And in Python, the way that I look at generator is that it's kind of like the stream API that exists in some of these other systems, because you've got essentially a stream of inputs, a stream of outputs, maybe a final result that comes out of this thing. And so, yeah, I can see similarities in these APIs to what we've done in so many other languages. But maybe, probably decades of iterations, through the coroutines API and the generator API, not the ability to pull away and be like, okay, what are the fundamental things underneath this that could create a better, more flexible foundation.
So back to the limitations. I guess there's a couple of things. Like, I think your retry does it not allow, fallbacks and jittering? Is that what they call it? And
like the schedule system.
Scheduling and stuff like that. And is that something that you can add and you just haven't done yet? But also, I guess the other kind of bigger question is, we've looked at some of the newer languages that are designed for AI generation. And we've looked at the ones that have effects in them. And one of the things that they have done mostly they haven't provided all of these library things, because the AI can generate that code. So it doesn't need special, human-oriented libraries. And I'm wondering, as we move more and more into that, how much of that stuff do you actually need to do versus, because the code is more and more just going to be AI generated, versus what the AI can just generate for you. Does that make sense?
Yeah, I think so. I think it's a very complicated question, actually, because there are factors when we're talking about AI and effect systems that I feel like are pulling in different directions. So one of them is that AI agents, they feed on feedback. And I think one of the great benefits of effect systems is that you get to import more stuff into your type system, like dependencies and errors and asynchronicity and a ton of other stuff. And in principle, that would allow you to catch. Yeah, it basically makes your type checker able to catch problems that it would not otherwise be able to catch, right? And I think that can be very powerful as a feedback mechanism for AI agents.
That's 100% been my experience, is that my AI can iterate so much faster when I'm using effect systems, because everything becomes quickly evident about what valid states actually are. And so I've been moving incredibly fast when I'm working on effect-oriented code with my AI, and I see the difference when I go to non-effect-oriented code. There's the longer iterations to get to validated state, longer and more.
Yeah, that's interesting, because I think on the flip side of that is familiarity, right? That effect-oriented programming is probably not exactly overrepresented in the training data for most AI agents, right? So if you ask an AI agent,
like the skills, like I've got, the skills that I wrote, I give it the documentation for the effect system. Like you probably put the GitHub repo for Stateless into your AI, so then it understood, had access to be able to understand.
Well, it went and combed through everything. Yeah.
So you're right, like base models, there's not a lot of good heavy weights towards effect-oriented programming. But if you augment your AI with the right information,
oh yeah, once it went through your library, it just started getting stuff right.
Yeah. So maybe it's less of an issue than you might think if you can just.
I think because there's so much Python code out there, whereas the ZIO code, well, and it was also earlier, but it wasn't. Yeah, that was much rockier of an experience. But this, I mean, my build system is also, it was also running everything through that, so that was a benefit. Yeah. But what I saw come out the other end was just like, yeah.
There's actually a benefit to a project like Stateless, which is probably not very heavy in the models yet, because then there's nothing to confuse it at this point, right? You give it the repo for Stateless, and it's like, okay, that's where I find all of the truth about this thing. Whereas, if Stateless has been around for 5 years or, as long as ZIO, then it starts to stumble on like, oh, what's actually right? What's actually the right knowledge that I should be using here? Because it's got all the old stuff, and then it doesn't really know how to distinguish the old stuff from the new stuff. Yeah. And so I've had to like build skills for ZIO to be like just you do it this way because that's the new way. But of course the model doesn't know that's the new way.
So I don't think we let you finish answering that previous question about.
No, but it would be an interesting experiment to run, right? To have some kind of toy problem and say, okay, try to solve it with just plain old Python, and then try to solve it using Stateless, and then try to measure how many iterations does it actually take to make it green, and how many errors does it then actually ship in the end also. So
there is another question. So with ZIO and a lot of effect libraries, one of the things that they do is they go, okay, well, your normal print you can't use anymore. You have to use our print, which is, the effect one. And you haven't done that. You said, okay, you can just use the normal library.
Well, so the way that I think about Stateless at this point is that the repository now provides kind of the core functionality, but it doesn't really provide you with like a standard library of stuff that you can use out of the box. You kind of have to define if you want a real console type that represents console in the abstract, then you have to write it yourself basically, and same for a lot of other stuff. But I think if the Python community at large starts to get interested in this type of this style of programming, I hope that would mean a proliferation of different libraries that you can install that kind of give you good integration with file reading and Fast API and some of the other popular libraries out there, right? So, yeah.
I think you're right. It's like once you create the right foundations that are effect oriented, building the library ecosystem around that now at this point is trivial, right? and creating wrappers around, whatever libraries that you would want to be effectified.
But I did find that a stumbling point when I was first trying to struggle with ZIO. It's like all of a sudden it's like, well, all of these extra libraries that you have to use instead, and I didn't know why. And I mean, it's just interesting to see that, oh yeah, it's relatively straightforward to use the standard library with Stateless. I mean, you have to do a little bit more, but
yeah. I mean, one fun trick that I have been meaning to document it is that if you use protocols to express your dependencies, you can actually wire up your protocol to match the shape of the module. And then you can actually inject the imported standard library module directly, and your type checker will actually verify that the module shape matches the protocol that you wrote. So you can get started pretty quickly with very little overhead, I think, which is a nice little feature of Python, that it has so great support for doc typing, right? That
Yeah, I think the two chapters make use of that.
One of the questions I had on that, which we were looking at in our book night this week, was that there didn't seem to be support or something in the variants system.
The covariance and contravariance and stuff.
Contravariance. And so in your protocol example, you had to like do a cast to get it to the right type. And I think you even document this on like subtypes. You have to like lower it into the type that's required.
Yeah, it depends a little bit on the type checker that you use because they don't really behave the same. So again, for the parts of your audience that are not well-versed in Python types are just annotation on Python code. And that means that there isn't like one list type checker with well-defined behavior. There are different type checkers that most of the time agree on how inference and stuff like that should work, but not always. So in Pyrite, for example, even though if you annotate something with its supertype, it is still treated as its subtype in certain contexts. And that leads to type errors when you're working with stateless.
Huh.
So to get around that, I've provided this. I use Pyrite mostly when
because I've been using Ty.
Yeah, I haven't tested Ty in a while. I think it's probably gotten a lot better. But what I found is that the style of inference in Pyrite just works really well with the types of expectations that Stateless has about how inference should work, especially around union types, which are used very extensively in Stateless. So it's kind of important for the experience of using Stateless that your type checker is good at inferring union types. And it's a little bit unfortunate that MyPy, which is a very popular type checker, is not very good at union types in general because it tends to infer a supertype of a union instead of preserving the union, which leads to some problems here and there.
Yeah, I kind of gave up on MyPy. So
is that general in the Python community?
Well, it was the original one, and it feels like it. I mean, my impression is it doesn't really keep up as well as some of the others, and I just kind of committed to Ty because I guess I trust Astral for whatever reason, and it's fast and they've been progressing a lot. So,
have you had any issues with the union types?
I don't think so.
Specifically,
I think Ty does the same thing that Pyrite does. So they do not unify types into their supertype in the same way that MyPy does. They take the same route as Pyrite does, which I think is
like preserving the algebra or something.
Yes, so it's like it's keeping the more specific type in most cases, which I think is what you want most of the time, unless you specifically annotate it as something else, right? Then, which is then the other problem that I have with Pyrite, that they then do not respect those annotations always, which creates other problems. But that's why this utility type exists, which is basically just the identity function, but which can, with type safety, tell your type checker that you actually need to interpret this type as its super type in this context.
Is that the type as, or what you have a name for it?
Yeah, it's called as type, I think.
As type. I was close. Just had it backwards.
Yeah.
And you have to do that because the inference is insufficient, or what was the reason for the as type?
So the way that handling, we haven't talked about that now, I'm realizing. But so the way that stateless works is that you yield these operations that I call abilities that then get handled by up the call stack, basically, in much the same way that exception handling works. And then the type inference there works such that when you handle an ability, that ability is eliminated from the effect type, so that tells you that it tells you when you've handled all the abilities that needs to be handled in order to run the effect, basically.
Yeah.
And in order for that inference to work,
like your run function takes essentially an effect, but that effect can't have any pending abilities. Like all abilities have to be resolved to actually, and that's like type system enforced, right?
Yeah.
Yes. I think you've got an example.
It won't. Yes.
Yeah. It won't compile when you have pending abilities
right
on the run. Yeah, it's cool.
So the issue with that today is that that requires union subtraction at the type level, right? Because you have some kind of union type of operations that an effect depends on. Now you're handling maybe a subset of them. Now your type checker has to figure out that these types actually correspond to a subset of the union that you have in your effect. And so what's left is then the resulting effect type, right?
Yeah.
Mm-hmm.
And that kind of works by accident today in Pyrite, where it checks it checks the type exactly, including type parameters. So it won't work with subtypes. It can't figure out that. Let's say that you have some abstract type called console, and now you have a mock console. It can't figure out that mock console is actually an instance of console. So supplying this here should actually eliminate that dependency.
So it's specifically on the elimination of types where the subtypes confuse the type checker.
Yes, exactly.
Yeah.
So
it's probably a pretty
I'm hoping that
thing to solve in the type checker.
Yes, but I hope that we will eventually have some of the same mechanisms that they have in TypeScript that you can use to address this type of behavior. And there is actually a PEP called type manipulation. I think it's 828 or something like that. I can't remember the exact number, but that would allow a lot of these problems to be handled at the library level instead of in the type checker level. Of course, the type checker needs to actually implement that PEP in order for that to work. But so
what's the status of that PEP?
I'm not sure. I think it's still being discussed. It's certainly not accepted yet. And I also imagine that there's quite a lot of controversy around it because it is it does make the type system in Python quite a lot more complicated than it is today, which I think many people feel goes against the spirit of the Python type system, which I can also appreciate. But for Stateless specifically, it would be a really powerful and useful thing.
So I sent you, one of the questions that I sent you was about the annotated, and of course this is a totally different direction than you've taken, but it occurred to me that the annotated feature would allow somebody to express a type system the way they wanted to, like, maybe look like a native type system. It would require a separate annotation process, or you wouldn't be able to use the regular type checker by itself to solve this. I don't know if you thought about that or looked into it at all or something, but it just kind of clicked in my head.
I did.
Like, wow.
Yeah. I did give it some thought, and I arrived at, I think, the same place that you arrived at, is that, I think there are two ways you could go about doing that. One would be to just have it as annotations that are like effect tagging. So they have no real consequence for the type checking, essentially, and they have no real, of course, they have no runtime consequences because type annotations never do in Python. I think that a lot of the power of effect systems comes exactly from importing more information into the type system. And so I'm not sure that would be very worthwhile. I think you would want to have some kind of static analysis tied to that annotation one way or the other. And then I think you're kind of probably half or even a whole step towards writing a completely new type checker to compete with the existing ones. So I don't know if there is much to be gained from doing that. Other than you would have complete freedom to define the semantics and the inference exactly as you want it for an effect system, right?
That's the appeal.
Yeah. But maybe in Stateless specifically, I've tried to, as much as possible, integrate with the tools that exist already. So an example of that is the async integration, which actually uses the async IO library for its async handling. And I felt that was preferable to writing a totally new async mechanism that would compete with async IO. even though it turned out to be pretty hairy to get that integration actually working, because I actually thought that it would be easy given that generators are coroutines and async IO also works on coroutines, but it just turns out that async IO have very different expectations about what can be yielded and what is being sent back. So
because the generator is probably not thread safe, right? Like it's a state machine, but they probably don't do any locks internally in a generator or something.
No, but I actually don't think that coroutines are thread safe either. So the ones that async IO uses internally. So that's probably a solvable problem. Yeah, exactly. Yeah, but also the state of the coroutine itself is not thread safe, I think. So
that's where things probably get dicey. But you did create an adapter to adapt from async IO constructs into your effect realm.
Yes, and that was actually a major redesign of the whole thing, because originally I had attempted to provide only the effects that ZIO provides. So that is type-safe dependency injection and type-safe error handling. But in order to do this trick with async IO that I do, which is that you're allowed to also yield coroutines, in order to do that and not lie about what can actually be yielded in the types, I had to allow you to yield more or less arbitrary values. So I do have one type constraint on what can be yielded, and that is that it has to be a subtype of this ability type that I was talking about before. And that's there really only for type inference reasons. That just makes the type inference work better, that the types are not totally unconstrained. But then I can have a wrapper around an async IO coroutine that is like an ability called async, which is really just a wrapper around the coroutine from async IO itself. And then my effect interpreter can just defer to the async IO interpreter whenever it sees an async IO coroutine. So it's kind of a hack, I think, but it does provide something like a bridge between the two coroutine.
It actually
types.
Feels more like a Kio or like a algebraic effect approach in that you would have an ability for async, and that's exactly what Kio does. If you're familiar with that one,
and it's exactly what Stateless does too.
Yeah,
I think it does too. The only thing is that it needs to be special cased for different reasons. So it's the one ability that you don't need to handle before supplying it to run, because run will actually
has its own
handle
interpreter
that
for async.
Yeah.
Or it
handles it for you.
Use the async IO interpreter in those cases.
I have to say, exactly. I like your naming too. I mean, like the needs and abilities, and supply, it's like and supply. And it's just like it's much more. I feel like it's more intuitive, more Pythonic, maybe. So
thank you. I mean, I did try to put a lot of attention into the naming also. I also stole a lot of it from other places, but So abilities I actually stole from the abilities terminology I actually stole from Unison, which also has
the first place where I heard the ability terminology.
Oh, okay.
And now there's capabilities. Scala now has capabilities.
Oh,
what's the difference between an ability and a capability?
I'm constantly confused by Scala. I can't say I ever really thoroughly understood it.
I wonder semantically what the difference between ability and capability is, and if that has any difference in like abilities versus capabilities in effect systems. Anyways, we were talking about how we were, curious why you didn't adopt the ZIO terminology for things, but then also grateful that you didn't at the same time.
Yeah, I mean, I think at one point I also considered calling effect IO, but because that's essentially what they do in ZIO, right? I mean, there's a C there, but that's kind of just marketing, I think. But I felt like that was too specific for what I was trying to do with this library. It's not really limited to IO, right? It's also dependency injection and error handling and asynchronicity and a lot of other stuff. Really, that you would want to express as an effect rather than something that just constrained to IO.
Yeah.
Even though a lot of the time that is what you're using it for, right?
Yeah, it's the most common use case, but I guess the intention of algebraic effects is that it can be anything.
Yeah,
you don't have to be. It doesn't have to be about I/O.
I personally found it kind of confusing, the focus on I/O, and because of is this just I/O? And and then when you go, no, it doesn't seem like it. So that I think it's nicer to not over focus on I/O, even though yes, it's mostly used for that.
But at the same time, there's kind of with ZIO, while a lot of the things you think about are I/O and thus a ZIO, then there's ZStream, and then there's ZSTM, and then there's like there ends up being many different like monetic data types that represent effects, different types of effects, and so there's a bit of a hidden complexity that you get into that's not immediately apparent. But then when you go into like ZIO or an algebraic effect system, it's like there can be many different types of effects, and let's just give that to you up front.
And that's much more useful to me.
Yeah. And they can all compose.
Yes.
And that's in the ZIO world, there is no implicit composition across the different effect types.
So what is the main composition mechanism in Stateless?
The main composition mechanism is union types, which is actually why you don't need higher kind of types to represent effects in Stateless. So when you need to depend on multiple effects, it's basically just adding a new ability to your effect type. So, which is to say, it's adding a new type of operation that this generator can yield now.
And that's the algebraic part.
That is that's a big part of the algebraic part, yeah. The other part of the algebraic part is that you then get to supply your own handler for the effects also. And that also happens with an algebra where you can handle a subset of the operations that were yielded, and then you would need to handle the rest of the operations somewhere else. And that is then subtracted from this union type again, right? So part of the algebraic effect story is usually also that you get to control how many times your computation is resumed in your interpreter, which is not something that you usually get with traditional MTL-style monads, right? So you have in the I/O monad, it will basically always resume the computation when the result is ready. Same for reader monad. But in algebraic effect systems, you get to decide at the interpreter level whether or not you want to actually resume the computation, which
because
makes
you
it
have the
possible
continuation.
Yes, exactly. So that means that you get to express things like error handling and other things with the same abstraction, because you can say, well, there was actually an error now, so that means that I should not resume the computation.
Yeah, and I think ZIO has a similar approach of errors are just I don't know. If you want to handle errors or aborts, those are represented as dependencies, and so then you need to decide how you want to handle those things. Yeah, it's similar. It's cool. So what's next? You still working on Stateless and moving it forward, and what's on the
I think for now, kind of the core library of it is sort of done until there are new opportunities to improve what's there whenever the language evolves. So one thing that I want to improve is the async story, but I don't think that that's really possible unless another PEP that I'm watching closely lands, which would allow you to do yield from inside of asynchronous or async functions. So if that happens, then that means that I can basically build my stateless interpreter on top of the Python coroutines instead of deferring to them when you need to do something asynchronous. So that means that you could use yield from whenever you want to do something with stateless, and you can use await whenever you need to do something with async IO in the same function. And I think that would be way more ergonomic probably than what you have today, even though you then kind of lose this async as just another ability type thing. I think it's more easy to follow what's happening because async it's already kind of baked into stateless, right? So it's not like that would also be the case if you start mixing async and yield from statements directly, then you can't really separate the async effect from all other effects. It's baked into the generator, right? But that's already the case. So I feel like I would not really lose anything there. And then the other thing is to try to, if this type manipulation PEP lands, try to simplify or improve the experience with type inference across different type checkers. And actually improve another thing that we didn't touch upon either, which is that errors have kind of their own separate typed hole in the effects type in stateless, which is a weird thing because you would expect that it could just be another ability it's
just
fail,
ORed
right?
together.
Yeah, exactly. But the reason it's not like that is basically also because of type inference, that it just doesn't really, the union subtraction part doesn't really work with major type checkers if you do that for various reasons. But if we could get something like the type union exclude operator from TypeScript, and that's part of this PEP, then I would be able to basically unify the concept of errors with the abilities concept. And I think that would be a easier to teach story about errors than it is today.
Oh, yeah.
It's not really clear why you need a separate abstraction for that. But and the truth is you don't, only for type inference purposes.
Interesting.
Wow.
Yeah, that'd be cool.
So the short answer is, I think what you,
like you don't want to
if there's anything to do right now, if there is anything to do right now, it's to build more integrations with existing libraries like Fast API or some other library that would make it easier for people to start using it in practice, or maybe building like a Postgres.
What's top of your list for library integrations into Stateless? Like, what are those side effecting libraries you use most?
I started this on Monday. Okay.
No, just like outside of Stateless,
I don't know. You'd probably have a better idea than I do.
I mean, file system maybe would be.
I guess. Yeah. I don't know. I don't have an answer to that. Yeah. I'm still trying to figure out the effect stuff. So I'm tailing behind.
I mean, you could
guys.
just start using it for error handling things.
Oh, yeah, that would be interesting to. I don't know if I covered or I should say we, because it's mostly Claude and then me coming up cleaning things up. So I'm pretty sure we covered maybe just using it for error handling, or at least maybe I should show that. Yeah. I'm sure all these questions will come up as I work on these chapters.
Yeah. But as you said, you're less than a week into this whole new world.
Oh, yeah.
Stateless.
Yeah. But I mean, so you feel like it's, it seems to me like the core of it is usable. And It seems like you feel that way too.
Yeah, I mean, it is still early days, and I don't know that obviously there aren't millions of people using it in production. So I'm sure that there are also ergonomic problems or bugs that will show up if enough people start using it. So in that sense, there would be work to do. But in the testing that I've done, and I've tried to do it fairly rigorously, it seems to me that the core of it is ready for use. And in fact, I am using it in production where I work now, and it hasn't caused any problems so far. So
that's huge.
I would encourage other brave souls to try the same. Maybe don't do it for the most critical part of your application, but I think that's what it takes for stuff like this to evolve, right, is to get used in practice. So.
Well, yeah, and also I'm hoping that it'll raise the visibility of it. I mean, certainly, because I know it was a year or so ago, I asked Guido and Barry Warsaw if they knew anything about effect systems, and they didn't. So hopefully we'll be kind of elevating.
We have some educating to do.
And I'm hoping that, once this book is what I feel like ready to publicize, maybe it'll open some eyes about this.
Well, and
that would
my goal with all this is like, let's help developers build better software.
Well, yeah, once you see, oh, I'm calling other functions and I don't know what they do, and there's no tracking of this, and it's just like, it's like exception specifications that failed. It's like, oh, the idea is there that you have to know what's going to happen, and we don't.
Yeah.
And once you see that, you go, oh, wow, okay. We can't build big systems without running into this problem.
Yeah. And now that we're having the AI do so much of our code authoring, so much of that is refactoring.
Yeah.
And John DeGoes is always called, like ZIO and effect systems, gives you the ability of fearless refactoring.
Well, yeah.
And I want my AI to fearlessly refactor 1 million times a day. And I think effect systems are one of the best ways to that. So
no, I feel like it's the barrier. You just look at the history of computer science and the barriers that we have unconsciously run into, and it's like, why can't we build bigger systems? And it's like, well, you need namespaces, or you need this or that, or you need need reliable error handling, or whatever it is. And then after the fact, we go, oh, that's why we couldn't build it. And I think this is what we're running into now, that most people are just, well, I guess we could use dependency injection, but that's really a lot of messing around. And I think, at some point in the future, we'll be able to look back and go, oh, yeah, clearly that was our problem. But everybody is not aware of it yet.
Yeah, I think the questions around AI are really interesting. I mean, I think a lot of the features in effect systems exist to make this kind of pure programming ergonomic, because, as you say, if you want to do dependency injection by hand or errors as values by hand, it becomes pretty verbose and unmanageable. And so that's why we've come up with all these abstractions, because historically speaking, it's been humans typing it by hand, and that's no fun. But now that an AI agent is doing it, maybe we don't need as many abstractions, but we still want the concepts of dependency injection and errors as values and all those things. But maybe you need less syntax and less frameworks. I guess I'm kind of shooting Stateless in the foot here a little bit, but maybe there's a future where
for reliable composition, the AI needs to know, what are my dependencies? What are the possible ways that this can fail? What are the any other kind of side affecting things that are happening?
And
if it can know those in the type system,
track of that itself, but it just seems like you want that to be automated. You want it to, because it's just going to
be explicit in the type system.
Yeah, exactly.
No, but what I mean is that dependency injection, you don't need an effect system to do dependency injection, right? That can just be a function argument. You don't need effect systems to do errors as values. But the reason we do it with effect system is because it's not very nice to do it without those without a system for it, right? But for the AI, it matters less.
Yeah.
Yeah, but that would still be the case, right? If even without the effect system.
I think it's the layers of composition. It gets you have to do a lot of traversals through things to understand the dependency requirements, and same thing is true for errors. Like if you call something, how do you know it throws an exception? Well, you could traverse through every call site and look at the not even the signature, because it's not in the signature. You have to actually look at the body of the thing to understand what errors could potentially be produced. And instead, if you have it represented in the type system that composes, then you just look one place, and you have all the information about dependencies and errors and
you're right.
all the things.
An AI could do that, and yet is that a good use of the AI? Is that, and I think even it's going to, eventually get bogged down by it. I don't know, maybe not, but then ultimately I think being able to have it human readable, like we interviewed the guy who created this Aver language, which is designed for AI generation, but also for human readability and verifiability. And I think that's, with robots, they found that the best the most beneficial thing is a human with a robot helper. And I think that's, we still, I see
symbiotic.
Human somewhere in the loop. There's a human. So, I don't know. I feel like it still needs to be wired in to the type system. So that's maybe.
Yeah, I definitely agree with that.
I don't know if we need all of the human affordances of all of the libraries support, because the AI can generate that. As long as it's tracking types, maybe we don't need to build all of these special libraries.
I think the example of that in the ZIO case is that ZIO has hundreds of combinators, like like, oh, you want to do this like operation on a ZIO, which is really just like 3 lines based on some other operation. And so while ZIO has these like hundreds of combinators, in the AI realm, maybe it only needs 10.
Right. Yeah.
And
the AI human affordances
can build. And it's nice as a human to be able to look at something and be like, okay, dot retry or whatever. But is that really necessary?
Exactly.
Maybe there's some fundamental ones like you need a fold and you need a flat map and you need those things, but everything else can just be assembled on top.
Provably correct things that can be assembled by the AI. And I don't know. I guess we're gonna find out.
Yeah, for sure.
But anyway, this is really fascinating. I was kind of amazed that I could do as much as I could with the library. I figured there's going to be some kind of stumble at some point, but so far it's been pretty amazing.
Nice.
So
that's good to hear.
Yeah, thank you for
do let me know if you do stumble on something.
I certainly will. Yeah. Now that we've communicated, I will. If I get questions, I will email you.
Sounds good.
Yeah. And we'll put links to everything on the show notes. But thank you for building this. I think for me, it makes Python palatable. And so that's a huge improvement. And for Bruce, it's been great to see him.
It's really
diving into this.
Hopefully
we'll get the rest of the world on board with.
Get over the hump of understanding effects.
Yeah. Bringing effect-oriented
in the
programming
language
to the
that I've used for the longest time, I think, at this point.
Yeah.
I gave up on C++ and Java a while ago. But I still keep coming back to Python.
All right. Well, thank you so much.
Yes.
Appreciate it.
Yeah, thank you. It was a pleasure.
Yeah, it's great to have you.
Okay.